Greetings, math fans. All right, so this is the review sheet for the counting chapter. And so let's get going here. The first thing I have on top here says, remember, assume repeats unless otherwise noted. All right, so if I don't say anything about it, you got repeats. Okay, very important. Okay, so let's get going here. Number one, in rolling a red die and a green die, how many ways can you roll a pair of dice to the exposed faces? And they give you a bunch of scenarios here. The key to this problem, math fans, is you got to draw a dice chart. Okay, we've done that many times, so it's really fast to draw one. Okay, and then remember it's 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, 8, 9, 4, 5, 6, 7, 8, 9, 10, 5, 6, 7, 8, 9, 10, 11, and 6, 7, 8, 9, 10, 11, 12. Okay? Very simple. Okay, so let's read it. Have a sum which is an even number greater than 8. All right, so we just kind of count them, right? If it's an even number greater than 8, that means it's got to be 10 and 12. So it's 1, 2, 3 10s and 1 12. So it's 4. Really easy, right? Have a sum of 2 or 12. That's easy. There's only 1 2 and there's only 1 12. So it's 2 possibilities. One die is 2 greater than the other. Well, do you guys agree that if I want to pick that, if it's one die is 2 greater than the other, isn't that rolling a 1 and a 3? Right? Because it's, if I roll a 1, the 3 is 2 greater. So 1 and 3, but can't I roll a 3 and a 1? Right? So if you look at the chart, you can find it. You can say 3 and 1 or 1 and 3. And then, of course, I can go 2 and 4 and 4 and 2. I can do 3 and 5 and 3. And I can do 4 and 6 and 6 and 4. Okay, those are my possibilities. So I have a total of 8 possibilities. So that's the answer for that one. Okay, and D, both die are even numbers. Again, you want to kind of write it out. We're not talking about rolling an even number. We're saying both die are even numbers. So just kind of looking at the possibilities, I can roll a 2 and a 2, a 2 and a 4, a 2 and a 6, right? I can roll a 4 and a 2. I can roll a 4 and a 4. And I can roll a 4 and a 6. And I can roll a 6 and a 2, a 6 and a 4, and a 6 and a 6. Okay, and if I count all these up, I get 9 possibilities. So 9 ways I can roll where both die are even numbers. Okay, and some of you guys maybe are looking at this going, well, you did a 2 and a 4, how about a 4 and a 2? Well, here it is. I did do the 4 and the 2. I made every possible combination here. Okay, so 9 possibilities. All right, move on here. Number 2, given 4 pair of pants, 3 shirts, 3 pair of shoes, identify how many outfits you can make. It's really easy. I can either do combinations or I can do slot method, right? I can do combinations because I say 4 pair of pants, I'm picking 1, and, so it's multiplication, 3 shirts, I'm picking 1, and 3 pair of pants, I'm picking 1. Okay, or I can do this. I can do the slot method, right? I can say, oh, well, there's 4 possibilities, 3 possibilities, and 3 possibilities. So either way I do it, I get the same answer, and I get 36. All right. Number 3, given the set of digits 0 through 9, find how many 5-digit even numbers exist. And now I've got 2 scenarios, with repeats and without repeats. So if you guys remember, this is like that special case that I warned you guys about. It's a 5-digit even number. Now the only one I really have to be concerned about is this guy right here, without repeats. But I want to do it a couple different ways for you guys. Let's just do, this is end in 0, and 0, and not end in 0. Okay, so it's a 5-digit even number. And if it's going to end in 0, there's one possibility. I come to the front one. Again, repeats are allowed, but it doesn't matter. I can't use a 0, so I have 9 possibilities. And then I am 10, 10, 10, because I can use all my numbers, right? Okay, and that comes out to be 9,000. And then not end in 0, is there's, again, it's an even number, so there's 4 possibilities. I come to the front one, I still have 9, because even though I use that number, it doesn't matter, it's with repeats. So it's 9, then 10, 10, 10. And so that one gives us 36,000. So if I add these guys together, I get 45,000. Okay? Now, you could have done this one all in one shot. And the only reason you could have done it all in one shot is because you are allowed to repeat. Because remember, the reason we do it in separate scenarios for like this next one that I'm going to do without repeats is because you use a number, then you get to the first spot, and you're like, well, did I use a 0? Did I not use a 0? Because that matters what that first number is. But if I can repeat, it doesn't really matter what that first number is, does it? Or what number I use at the end, because I can use all 9 numbers in the beginning. So real quickly, I'm just going to do with one case for this one and show you how you get 45,000. Again, the last number, there's 5 possibilities. I come to the first number, there's 9 possibilities because I can't use a 0, and the rest of these are 10, 10, 10. And if you multiply all those out, you wind up getting 45,000. Okay? So that's kind of nice, right? That's I can do it in one scenario. This is the one that I really need to be concerned about, is without repeats. Probably the one you're going to see more often. Okay, so again, I'm going to do 5 slots, and this is ending in 0, and this is not ending in 0. So if it ends in 0, it's 1. I come to the front spot. I can't use 0, so there's 9 possibilities. So now I've used the 0, and I've used one of these numbers. So you guys agree that this next one is going to be 8, and then 7, and then 6, right? Okay, if I don't end in 0, there's 4 possibilities. I come to the front spot. I can't use the 0, and I can't use the number I used at the end, so I have 8 possibilities. Next number, I can use the 0 now. I have 8 possibilities, 7 and 6. Okay, and so this one I get 3,024, and this one I get 10,752. So if I add those up, I get 13,776 as my answer. Now again, you can't do that one with one in one scenario, because as I explained, you don't know what you use at the end to give you that correct first number in the beginning. Okay? All right, let's do the next one here. How many numbers exist less than 300? Remember, this is a different kind of problem. It's 3 blanks, 2 blanks, 1 blank, as opposed to the top letter A was a 5-digit even number. Okay, this is how many exist less than 300. And again, I have with, repeats, and without. So it has to be less than 300. Do you guys agree that it can only be a 2 or a 1? So it's a 2 here, and then I can use any number, all repeats, so 10, 10. So I end up getting 200. And then, again, you can't start with a 0, so there's 9 possibilities, and I can use any number, so it's 10, so I get 90. And here I can use 0 through 9, so there's 10 possibilities. Don't say 0 through, don't say 9 numbers there, because you can use the 0 now. Okay, so if I add all those up, I get 300. Okay, now the same problem without repeats. Okay, this is going to be same thing, right? I'm going to start out with the first number. It's going to be a 2 because I can use a 1 or 2. I used one of those numbers. Now I have 9. And then I use one of those numbers. I have 8. Okay, so I get 144 for that one. And then this one, I can't use a 0, so it's 9 possibilities. And now I use one of those numbers, but 0's back in the pot, so I have 9. So you get 81 there. And then, of course, here it's again 10 because it's 0 through 9. And then if I add those numbers up, I get 235. Okay? All right, letter C. How many 5-digit odd numbers exist with alternating even odd digits? No repeats. So if it's an odd number, that's our first restriction. So this has got to be odd. And if it's alternating, let's just go backwards. Even, odd, even, odd. Okay, so how many odd numbers do I have? Well, 5. How many even numbers do I have? 5. Okay, I use 1. So I'm kind of going backwards. Doesn't really matter, but I definitely want to fill this one in first because it's got to be an odd number, though it doesn't necessarily matter that much. And then we go 4, and then 4, and 3. Okay? And so we multiply all the top numbers up, and you get 1,200. All right, So let's keep going here. Given the letters A, B, 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 C, D, E, how many arrangements exist? Okay, so you guys need to remember this is, we're going to count up all the letters and we get 8 letters. And you put repeats. So 2 A's are repeated, 3 B's are repeated, and that's it. So don't forget, use parentheses, and you get 3,360. Okay, number 5, very important problem. We've had a lot of practice this one. You guys definitely need to know how to do this one. And basically it's just remembering the formulas for a permutation. So let's set this up. It's NP5, so it's going to be n factorial over n minus 5 factorial equals 12 times n factorial over n minus 3 factorial. Now, I could divide both sides by n factorial, so the n factorials cancel. That's kind of nice. And let's kind of multiply this out. I have, if I cross multiply, 12 times n minus, let's show a little work here. Okay, and let's expand to n minus 5. Now, guys, I want you to be careful about is kids tend to make a mistake and do n minus 5. Then the next one is, n minus, what is it? It goes less and less and less. Do you guys agree with that? So the next one is not n minus 4 because that would be going up. Make sure you go down, otherwise things are going to get messed up. So it's n minus 5, n minus 6. We're going down, right? N minus 7. Keep going. And that's equal to, again, n minus 3. We're going to get less and less. So n minus 4, n minus 5, keeps going down. So you guys agree that I can divide and things cancel, like the n minus 7s cancel, n minus 6 cancels, n minus 5 cancels. And what I wind up with is, if you look at it, I just have a 12 here, and this n minus 3, n minus 4. So let's write that out there. 12 equals n minus 3, n minus 4. Okay? So just kind of be careful about that. And I need to distribute this. It's going to turn into a nice friendly quadratic. So you get n squared minus 7n plus 12. And I can subtract 12 from both sides, and this is really nice. So I get n squared minus 7n equals 0. So n, factor out an n minus 7 equals 0. So I get n is 0 and n is 7. Well, it can't be 0 because, again, you can't have 0 things to choose from. Can't be negative, can't be 0, can't be a decimal. It has to be a natural number, a number 1, 2, 3, 4, etc., an integer like that. Okay, so that is your answer. N is equal to 7. Okay, keep going here, math fans. 6, you are required to read 4 books from a list of 11 great American novels. How many ways can you select those 4 books? It's definitely a combination because you are selecting a group of books, not ordering them, not saying I'm reading this one first, this one second. It's a group of books. So it's 11C4. That gives us 330. How many ways can a committee of 5 students be formed from 11 students if Steve must be chosen? Hey, that's me. Hey. Anyway, this is kind of that baseball problem where you got to pick 5 students, but somebody's already chosen. So I don't really have 11 to choose from anymore because Steve's already in the group. So do you guys agree? It's 10 to choose from, and I'm only picking 4 because I already picked Steve. So Steve comes out of the 10 and out of the 4 because he's one less person to choose from and one less person to choose. So it's actually 10C4, which is 210. All right, number 8. A box contains 8 black and 3 or 4 green marbles. How many ways can 5 marbles be chosen? So if I just said in general, first of all, this is a combination because how many ways can they be chosen? There's no order here. I'm just saying how many ways can I choose black and green marbles? Okay, I'm not saying I'm choosing this one first and this one second, this one third. So it's definitely a combination, and there are a total of 12 marbles, and I'm picking 5. That's really easy because I'm not distinguishing or differentiating between black and green marble. I'm just saying, hey, how many ways can I pick 5 marbles? So it's 12C5, which is 792. B, and how many ways can 3 black and 2 green marbles be chosen? Well, now I've got 8 black marbles, and I'm picking 3, and, so it's multiplication, I've got 4 green marbles, and I'm picking 2. Okay, so I get 336. C, and how many ways can 3 marbles be chosen if at least, ding, 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 at least, whoop, whoop, whoop. Sounds like a bearing problem. Okay, if at least 1 is green. That's really, really important. So I'm picking 3 marbles, So it's either going to be one green one, two green ones, or three green ones. Okay? So if I do one green one, there are 4 green marbles, and I'm picking 1. And then there are 8 black marbles, and I'm picking 2 because I'm picking 3 marbles total. So again, the number on the left, it's 4 and 8. That's the number I'm picking from, right? 4 green, 8 black, and then the number on the right is the number I'm actually choosing. I'm picking 1 green one and 2 black ones. Okay? So it's this, that's why it's multiplied, because it's that and that. Or, don't forget, or means plus. Okay? So 2 green, so it's 4C2 and 8C1, 1 black, or 4C3, 3 green, and 0 black. Okay, so if you multiply all that out, you get 164. But man, look for that at least. So important. Don't miss that. Okay, number 9. How many ways can a committee of 4 students be formed from 10 students if each student will serve a different position on the committee? Okay, so it's a little bit different because I know you guys are looking at going, oh, hey, this is a committee. But if each student will serve a different position, that's like saying this one is going to be president, this one's vice president, secretary, treasurer, etc. Okay, so this one is it's a permutation, and there are 10 students to choose from, and then I'm choosing 4 of them. Okay, so we get 5,040. Number 10, given 10 books, 2 are in one box set and 3 are in another, how many ways can the 10 books go on a shelf given that the books in a box set must stay together? So this is like an arrangement. This is our bride and groom problem, right? So this is the deal, though. It's like the bride and groom were together, so that's like one slot. Well, this one, I have 10 books, 2 are in a box set, and 3 are in another box set. So that's kind of a group in itself. So here's the deal. That's one box set, and that's another box set. And there's 10 books total. Now, it doesn't say where these things can go, but if that's already 5, let's just draw 2, and then they don't have to be in any place. So this is treated as another slot. You guys agree with that? So again, this is like the bride and the groom where they can stand anywhere. So it's the bride and groom slot moves around. Well, this is the 2-box set that moves around and the 3-box set that moves around. Okay, so if I count the number of slots, and let me put this in red. Truly the number of slots is 1, 2, 3, 4, 5, 6, 7. Okay, so that's going to be 7P7. And then each box set, like the bride and the groom, that's going to be 2P2 and 3P3. Of course, it's multiplication between these. And we get an answer of 60,480. Okay. All right, number 11. Given a standard deck of playing cards, cards are chosen at random. How many, and then we got all kinds of different scenarios here. How many 5-card hands exist? Remember, card problems are combos. Combinations, all right? So there are 52 cards in a deck. Whoa, nice 2. And I'm picking 5. So my answer is 2,598,960. Ooh, current balance of my checking account. Sweet. It's coincidental. Okay. 5-card hands exist that have 5 of the same suit. All right, so let's think of a diamond. How many cards in a diamond? There are 13 cards. You can say 52 divided by 4 is 13. So 13 diamonds, and I'm picking 5 of those. Or 13 hearts, or 13 spades, or 13 clubs. So it's the same thing as that times 4, because I could write 13C5, and I could write it 4 times, but just know that there are 4 suits, so multiply it by 4. Okay, so again, 4 suits. So we get an answer of, it's 1287 times 4, which is 5,148. Okay. The next one, how many 2-card hands exist if only 1 card is a queen? So think about it. 1 card's a queen. I have 4 queens to choose from. That's why the 4 is there, and I'm picking one of those. All right, and what are my other possibilities? Well, if there are 52 cards total, I now have 48 to choose from, and I'm picking one of those. So I get 4 times 48 which is 192. Okay, remember that left number is the total number I'm picking from. That right number is how many cards I'm picking. Okay, D. How many two-card hands exist if both must be face cards? Well, how many face cards are there? Well, remember, Jack, Queen, King are face cards, so there are 12 of them. So it's 12C2. And you get 66. Okay? E. How many two-card hands exist if they make a pair? Well, now you got to think. A pair. That means a pair of twos. So if I just do it for the, let's do it for the twos. Isn't that going to be 4 twos? And I'm picking 2 of them. And how many are there? There are 2s, 3s, 4s, 5s. So there's 13 different possibilities. So really, I multiply this by 13 because there are 13 ways to do that. And so 4C2 is 6 times 13 is 78. Okay. F. 5-card hand. How many 5-card hands exist that have 3 of a kind? Great problem. 3 of a kind means let's do 2s again. Which now, just knowing that I'm doing 2s, I'm going to have to multiply that by 13, right? Because I got to do 2s, 3s, 4s, all the way Jack, Queen, King, Ace. So anyway, 2s, it's going to be 4 2s to choose from. I'm picking 3. It's a 5-card hand, so the other cards, it's going to be 48 other cards, and I'm picking 2 of those. Because again, the left number is got to add to 52 in this case because I'm picking from all the cards. And the right number, I'm picking 5 cards, so it adds to 5. And it does. 3 plus 2 is 5. And then multiply that by 13, that total number. So we get 58,656. Okay? All right, number 12. Okay, now we're using the binomial theorem to expand. And so I'm going to write kind of small here. But remember, it's power of 4, so it's going to be 4C0. And remember, it's the first term. And then 2y, the second term. And that 0, the bottom number always goes with this one. And then they have to add up to 4, so that's a 4 there. Okay? And so let's write this all out. It's going to be 4C1. X 2y, so this is the first and this is to the third, plus 4c2 x and 2y, and so this is going to be squared, and then this is also squared, and then 4c3 x 2y, and this is going to be to the third power and to the first power, and then plus 4c4 x 2y, and this is to the fourth power, and this is to the 0 power. Okay? So 4c4 is 1. That's x to the fourth. That is 1. Okay? 4c1 is 4. That's x cubed. That's 2y to the first, so it's just 2y. 4c2 is 6. X squared. Common mistake I'm about to do here now. Well, I'm not going to do it, but common mistake is just writing 2y squared. It's the whole thing that's squared. So it's 4y squared. Very, very important. Okay. So 4c3 is 4x. Again, 2 cubed is 8, and y cubed is y cubed. And then 4c4 is 1. X to the 0 is 1. 2 to the fourth is 16. Y to the fourth. Okay? If you leave it like that as a final answer, you're going to lose a point because it needs to be multiplied out. No parentheses left in the final answer. No parentheses. So if I multiply it all out, I wind up getting x to the fourth plus 8x cubed y. Okay, again, don't leave it as 4x cubed 2y. That doesn't make sense. You got to multiply the coefficients out. Plus 24x squared y squared. Plus 32xy cubed. And plus 16y to the fourth. That's your answer. Okay? The beauty of using binomial theorem is finding the sixth term. You don't have to expand it all out. Okay, if I want to find the sixth term, remember it's 8C5. Okay, it's always one less because the sixth term, remember when you do combinations, you always start with 0, so count your fingers, 0, 1, 2, 3, 4, 5. 5 in the bottom is the sixth term. Okay, then the rest of it is actually easy as long as you know how to set it up. Remember, this is 4x here, this is negative y, and that bottom number goes here, and those numbers have to add up to 8, so it's a 3. So I multiply that out, and I get 56 times 64x cubed times negative y to the fifth. Be careful of negatives and raising to a power, okay? If it's an even power, make sure it becomes positive, very important. Anyway, don't leave it like that. Multiply it all out. We get negative 3,584 x cubed y to the fifth. Okay? Pretty mellow. Middle terms are really, really easy. It's always going to be an even number like this because it's the only way you're going to get a middle term. And basically, you just do 8 divided by 2, which is 4. So it's going to be 8C4. It's so easy. And these are 4x to the fourth. That's why those numbers are the same. And negative y to the fourth. Oh, so easy. Just be really careful about it. Okay? You multiply it out, and you get 8C4 is 70. 4 to the fourth is 256. X to the fourth. And negative y to the fourth, again, it becomes positive. So you can either use your parentheses or just know that it's positive, and then you get y to the fourth. So your final answer for this one is 17,920. Oops, that's a 20. 17,920 x to the fourth, y to the fourth. Okay, let me move that up a little bit. Okay, there you go. I moved it up, and I also made it a little bit neater. Okay? So that's it, math fans. Bunch of different problems. I would definitely, when you're studying for this has just got some of the problems on it. I would look over all the note sheets and the worksheets. You know, even the with the quiz, studying for the test. I would definitely make sure you know what you're doing because there's a lot of stuff involved here, and just make sure you're good with permutations and combinations, and kind of how to handle card problems, etc. All right. That's it, math fans. Have an outstanding day. Adios. Goodbye.